For every generation, the word computer has been redefined. Starting as a machine that solves complex arithmetic problems, it has evolved into what we know and love today. One concept in computing that has stuck with it from the beginning of time is automation. If you think about it, everything you do on a computer is pretty much an automation of something you had to do without it. Over the years, the progress of computer science has been measured by just how much we can automate. Every computing breakthrough, from networking and the internet to artificial intelligence and large language models, aims to automate everything possible. At the center of most of these solutions is programming. Rather than building a machine to solve a specific problem, why don't we build one big machine and tell it exactly what to do? This idea is why you and I have a place in our society, as techies who chime away on our desks thinking of creative ways to solve problems and automate. Artificial intelligence and generative AI. Of course, our obsession with automation as computer scientists and engineers led us to find better ways to tell computers exactly what they should do for us. Abstraction is why we don't have to know the underlying architecture of every machine we write programs for. Each new paradigm reduces the need for explicit instructions when programming machines to work for us. Large language models, LLMs, like ChatGPT, extend this journey by shifting from strict programming to natural language interactions. This is the ultimate abstraction, teaching a computer not just to follow commands, but to understand context and intent. Today, developers are leveraging LLMs in ways we couldn't have imagined a decade ago. These tools seamlessly integrate into programmers' workflows at all levels, from generating boilerplate code to debugging and brainstorming solutions. It's about saving time and enabling developers to focus on higher order problems. Intellectual demand and supply problem. Like every other profession, how much someone is willing to pay for your service depends on how much they need the service, demand, and how many alternatives they have, supply. As software engineers, the commodity we sell is our knowledge and experience in building quality software systems. With generative AI tools like ChatGPT, the time taken to pick up new concepts or get familiar with a new domain is exponentially reduced. To top it all, software developers become more productive, as routine and context-free tasks in their day-to-day jobs can be automated with AI. What would normally take 10 engineers to build now takes at most 6, reducing the incentive for companies to hire large teams. The supply of intellectual resources is higher than ever, and companies realize this. It shows in the recent layoffs and changes to hiring policies. Many companies now prefer to hire 3 people to perform a task that typically requires 5, compensating each of them with higher salaries. The consequence? We see less overspecialization in the tech space. Jobs that require less creativity, ops-centric jobs, are slowly eliminated in smaller companies. Just too many CS majors. It's no news that more people are enrolling in CS or CS-related degrees to pursue careers in technology. According to the Computing Research Association's CRA, Generation CS report, undergraduate CS enrollments have been increasing since 2006, surpassing previous booms in the mid-1980s and late 1990s. This upward trend is evident in specific institutions as well. For instance, Purdue University's Department of Computer Science reported an increase in undergraduate majors from 438 in fall 2008 to 1,490 in fall 2009-2016. The tech dream has been heavily marketed, promising that studying computer science for 4 years would lead to a 6-figure salary. This narrative isn't just a fairy tale. We've seen it come true repeatedly. Additionally, coding boot camps and self-taught programmers have joined the trend. With 6 to 12 months of commitment using online platforms like YouTube or Udemy, many have successfully secured junior positions at major tech companies. This success has caused an oversaturation of people enrolling and graduating from CS degrees and boot camps, all struggling for a place in the tech industry. This oversaturation has caused a lot of companies to lose faith in our educational system's ability to produce quality engineers and computer scientists. Graduates must gain experience beyond internships, engage in tech communities, and maintain a stellar LinkedIn and social media presence. Even all this does not guarantee landing a high-paying 6-figure job immediately after graduation. It's not impossible, it's just harder than it used to be. My opinion: is AI ready to replace human engineers? AI is good at spewing syntactically correct code, but it falls short in areas that require deeper reasoning, creativity, and contextual understanding. They are not autonomous in making the best engineering decisions. They cannot fully evaluate trade offs, optimize solutions for specific use cases, or foresee the long term implications of design choices. Moreover, AI struggles with asking the right questions, a skill that lies at the heart of effective problem solving and system design. Understanding a project's requirements, probing stakeholders for clarity, and adapting to shifting priorities are challenges that AI, at its current stage, cannot address. These tasks require emotional intelligence, critical thinking, and a nuanced understanding of the broader context, qualities inherently human. Are rookie engineers cooked? If you're new to the tech space, get your hands dirty. Over reliance on LLMs can hinder growth. Use them for boilerplate code or quick documentation searches, but let them enhance, not replace your learning. Focus on understanding the underlying concepts, debugging errors yourself, and building projects from scratch. This hands on experience will strengthen your problem solving skills, which are critical in real world scenarios. Conclusion: in light of these insights, it's clear that the role of programming is evolving, but remains indispensable. The tech space has evolved to one where knowing every built in function in Python or Java is no longer as important as it used to be. Instead of being replaced, developers now focus on creativity, strategy, and innovation. LLMs haven't taken our jobs, they've made them more exciting. Do you think programming is still worth learning in 2025? Leave your comments below. If you find it interesting, please like and subscribe to follow the next videos. Thanks and see you again.